Hello, my name is Dave Sexton. This is the first video in what I'm planning to be a series of videos on reactive programming using a reactive-first approach. So we'll be building an application, a chat application, and I have the spec online already published to my GitHub repo, which you can see right here. There's the link. And we'll be starting with a blank solution, clean slate. I'm going to solve all the problems that I need to solve and record every decision, good or bad, for better or for worse. And hopefully this will be a learning experience for everyone involved, including myself. So let's start from the beginning. I have a blank solution here. I have a README file, which I recommend you go and read. I'm not going to read it here, but it's online, like I said, on the GitHub repo. There's some prerequisite knowledge you should have before getting into this. I'm not going to get into details, but you should read up on it if there's any concern. And I want this to be realistic, so we're going to be building a chat application with the specification, again, also in the GitHub repo, that you could read on your own time, but we'll pick out the parts that matter as we need them. So as a matter of fact, I think we should just dive right into the code and start with the parts of the spec that are the most interesting to us. All right, so I'm going to start by adding a project here. And I'm going to target .NET Standard so that way we could reuse it across platforms. We're not going to be doing anything except for WPF, rich client desktop development for now, but I want to keep things as general as possible for the future. So we'll call the application chat. Good enough for now. I'm not going to build an interface yet. We're going to start right at the core of things. The reason is because I want to explain just sort of the essence of reactive programming as I see it. This isn't going to be a deep dive into it by any means. It's just to kind of get you aligned, your thoughts aligned with the way I'm thinking about this, so we could proceed together without much confusion. So the way I see reactive programming in general is a way to respect time in a specification. Time is, something that cuts through almost every rule in a specification, whether it's stated explicitly or not. And I think it's important to recognize that time is such an important factor in everything we do as programmers. And when you don't respect time as a factor, you end up getting applications that implement business rules in a way that's sort of like a piece here, a piece there, and you have multiple types implementing, with here's a dictionary and here's the state in a different class, and this class depends on 3 other classes, all to implement like a single business rule. When you go to the spec, the rule is obvious and simple and can be written in a way that's very elegant. I want the code to match, right? So that's the goal here, using reactive programming in a way that will allow us to respect the time factor in the code and write code that's clean and to the point, so it's maintainable. Some might call it a declarative programming model, right? So we're going to start by analyzing the spec here, not in much detail. I suggest you read the spec in your own time if you're interested in where we're going with the application. But I want to start with just calling out some business rules that we could implement now and talk about how to go about implementing them the way that would be, in my opinion, the reactive-first way. So we start with the concepts of input and output. When you're building an application, normally, the classic way of doing it is all the nouns become types or state, right? All the verbs become methods or behaviors. So object-oriented programming prescribes that we define a type with state and behaviors that are cohesive, all in the same type. So that's a nice approach when you're modeling things that don't have to do with time at all, right? They're static in a sense. But obviously the things we're going to be dealing with, all modern applications, and pretty much you might argue any application that has a user interface or connects to a service, something data-driven and natively asynchronous, has to deal with time as a factor in almost every rule of the application. Business rule, presentation, logic rule, whatever it might be. So when you look at a spec like this, you'll notice keywords like when, and we tend to like make those into events, right? We'll model those as events in the programming world, and that's nice. It's kind of reactive. Event is a reactive kind of programming model in that it deals with a callback mechanism, but the problem is events are not composable, right? So when you start dealing with events, you end up picking and choosing events that make sense as events because they're written as events in the spec, like when a connect button is pressed. So you have like a click event on a button. But then the problem is you have a click event on a button, you have a text change event on a text box, and then you have to, in some way, tie these together to implement a business rule when the connect button is pressed and the username is valid, and the service URL is valid, et cetera, et cetera. And the problem ends up being you end up having multiple places where the business rule is located. It's spread across multiple methods or multiple types, and you have different states and different flags, and here's a dictionary over here, and so on and so forth. And it just becomes really confusing. Somebody looking at your code, it's not immediately obvious to them what the essence of the operation is that they're looking at, or if they're looking for a particular business rule where it's implemented, it's hard to find it, right? And all the dependencies and everything becomes complicated. So what we're going to try to do is try to do something simpler than that, and we're going to do it by being consistent. So just because we see a when here and not here doesn't mean that this rule shouldn't be an event and this one should. And we're not going to immediately go, there's a noun, so let's make a type, or there's a verb, let's make a method. I know that might be a little bit of an old school kind of approach, but it's still kind of the general essence of what's happening when you're building an object-oriented first application. And events, like I said, are kind of spotty around it. They don't really solve the problem in the way we want them to because they're not composable. So they don't make anything much. They don't make the whole process much easier. They actually, in some cases, actually make it much more confusing because you end up having to flip back and forth. In the same business rule, you're at an event, and now you're in a method, and now you're invoking a function, and then you're setting some field value, and then now you're waiting for another event to be raised, and it just becomes convoluted, right? Asynchronous spaghetti code, if you will. What we want to do is we want to solve this problem in a very direct way, and like I said before, declarative manner. So let's start from the top, and let's see if there's anything that we can call out here as distinguished between input and output. As a matter of fact, it might make sense to actually create a note for this. Notes as I'm doing this. Yeah, you know what? Maybe I'll do that. So we have the spec here. All right, so the spec is more like the technical specification from like the business perspective. Let's add another file, which is going to be the specification from the reactive-first perspective. So let's create a new file here. Did I add existing item? Yeah, add existing item. Okay, doesn't matter. I'll just do it this way. And let's call this, how about reactive spec? I don't know. Probably good enough. All right, let's do a split view here. And I'll just collapse this document part. You know what? Let's do, the resolution is terrible here because the video because of the video I'm trying to record in a resolution that's appropriate for multiple devices, but to view, to watch the video on multiple devices, like mobile devices. But it really makes it difficult to do programming the way I like to program. I sometimes like to have a few different vertical or horizontal separation of windows and documents rather, and do things at the same time. Okay, so let's start from the top here. The user can set their username before connecting, right? So let's think about, this is the tricky part to the approach because it's sort of inverting the way you think about simple things like this. The user can set their username before connecting. That doesn't seem like it's reactive at all, but it is, or it could be. We can model it as a reactive, we could take a reactive approach to modeling this. Let's see how that would happen. But before we get to that, let's just, in this reactive spec document, I want to sort of create an outline here so we have something to fill in. Basically, what we're dealing with here in reactive programming is input and output. We're trying to figure out what's the input and what's the output. And we're going to look at them from a reactive approach so that we can build code that essentially reacts to input to generate output. Right? So the reactive part of our program is sort of the glue between the input and output of the program. And because it respects time, it's inherently asynchronous, right? The input is not something that, we're not invoking the function between the input and output in order to generate the output. We're not passing an input. We're writing code that will await input to be passed to it. So it's like a push-based approach rather than pull-based, right? We're not going to imperatively invoke the function. We're going to await our function to be invoked. So because of that, it means that we're going to have to figure out what the input and output is in our spec and try to figure out where time, exists there. So that's one aspect of it. The other aspect of it is the streaming nature, right? So when looking at the spec, it's quite easy to ignore the fact that pretty much everything is a stream. When we tend to model programs in a sort of piecemeal way, right? So this first bullet point says the user can set their username before connecting. We would tend to say, okay, well, set is a verb, right? It could be a property like username on a user type or something like that, or a program has a username property, and then we have a flag that says is connected, and if you try to set the username after it's connected, we throw an exception, right? That's kind of the object-oriented way of approaching something like this. But what might be surprising is to notice that this could also be looked at as a stream, an asynchronous stream. For example, we have to assume that if the user can connect, then the user can disconnect. And we don't actually have to assume that. I mean, that is a requirement. I have that written in here as part of the feature set or whatever, wherever it is. Clearly, the user should be able to disconnect. Maybe disconnect, change their username, and reconnect. That's fine too. We'll support that. Because we're supporting the ability to disconnect, it means that it's possible within the same run of the application for the user to set a different username. If we ignore the state related to it, the connection or disconnection, we could see this concept of setting a username as an asynchronous stream of usernames, right? We can see that we can model this one line here, even it's weird as it sounds, we can model this one line here as an observable of string, which is essentially to say that when you subscribe to this observable, you will be pushed usernames, right? New usernames. Now, there's also this other aspect to it, which is before connecting. But before connecting is also explicitly introducing the concept of time into this rule. So we now have this concept of being able to say, before the user has connected, we could subscribe to the observable that pushes us strings which represent usernames. And the user might change their name multiple times before actually attempting to connect. That's also a possibility as well. And maybe we could use that to perform validation on the username. If it's an empty string, it's invalid, for example. So you could see just doing something as simple as changing what would normally be like a little verb that would turn into a function on a type somewhere or a property setter just to accept a single string with state somewhere else, like flags for connectivity and so on. Just by looking at that simple problem, very common problem that's modeled in object-oriented terms as I've just described, as a reactive problem modeled as an observable, it opens the possibility to now defining the program in a declarative manner, where we could talk about time as part of the problem, right? We could say, before the user is connected, listen for usernames coming in, right? And do validation, and then have downstream observables or queries subscribing to that observable, and so on and so forth, and composing the application in such a way that allows it to read very much like the spec. Right, and I'm not suggesting that what I've just described will make perfect sense to you yet. That this is the whole video series is meant to be a proof of this. So that's really the premise, and that's what we're moving towards. But the only way to get there is to start from the spec and figure out which parts map onto this reactive model, or how to map them onto the reactive model in the way that I've described. So we're going to start from there. So we have the input and output outlined here, and like I said, we also want to think in terms of observable streams. So instead of defining this rule as, just to be clear here, the way we might do it in the OOP terms, and we could say this is the RP terms, and this is going to be the OOP terms. So instead of doing it the way we would normally do it using object-oriented programming, and that is to say, when I press enter deletes the dashes. Oh, this is markdown. I forgot. The dashes probably have some special meaning. Can I do equal sign? Does that do like an underline? Doesn't actually do anything. Ah, I forgot. This is the real markdown format. There you go. Okay. So in the object-oriented programming way of doing this, we might say, okay, we need this concept of a user, right? So we'll call it a type. Oh, we could be more specific. We're in C#. We'll call it a class, and we'll have a string property called username, right? And connecting, we'll just ignore that for a moment, whether you're in the connected state or not. But normally you would then model that as a field, a Boolean field somewhere. Are we in the connected state? Are we not in the connected state? And you have to have the service has to know about or not the service, but the state of the client connected to the service has to be aware of the username, and some other component, some controller or whatever pattern you end up using has to be able to check both of them. And you see the dependency tree just grows and it gets crazy after a while. It could potentially get crazy after a while, I should say. Not always. Sometimes it's nice, but here it's simple. But I just wanted to point out that this is the way we would normally do it. It's the way we're more comfortable with, right? If you're not used to reactive programming. So now we want to map that onto a more reactive, not more, but a reactive way of doing this. So we need to think of this in terms of input and output. So what's the input? The input is essentially an observable of string, right? So can I do this as code? Yeah. Let me just format this a little bit so it's not too messed up here. Yeah, it looks good. I'm just looking at this side here on the right as I'm writing it, by the way. So so we could think of this first rule as being an observable of string, which represents usernames, right? So it'd be like that. And here we could do this. Is it 4 or 3? I always forget. It's 4. Okay. Okay, so that's the way we would normally do it. And then up here, we want like an observable string of username, right? Now, this is input, right? Which essentially means it's kind of like just a setter. For those of you that don't have properties or the concept of properties in your language, a setter in a property is something that's really just a method that looks like this, right? So that would be what gets generated for us automatically. Oops. It would look something like that, right? But this is the CLR knows how to deal with this because it's a normal method. Properties have additional metadata associated with them, so they're a higher level concept that C# allows us to use. But essentially, when you see something like this with a getter or a setter, it gets translated into the intermediate language as a method that looks similar to this. Okay, so you could just make that mental change in your mind. Actually, I would recommend not making this mental change. For the rest of the series, you're going to see a lot of properties, I'm sure. So just get used to the fact that these properties are really just ways of grouping two methods together that are related in some way, like a getter and a setter for a specific purpose. That's what a property is, right? So typically you would see a getter and a setter, and it would look like that. Right? You would do something like that. And this is essentially what gets generated, okay? So here we have a setter only. And the reason why is because this is input, right? So the input into our reactive program is an observable of strings. Observable being an interface that you can subscribe to in order to be pushed string notifications, right? Notifications of the form of the type of a string. So the user can set their username. That's like a user pushing in a new string to us, right? As a matter of fact, it should be called usernames because it's potentially more than one, right? The user might push multiple usernames throughout the lifetime of the app. Okay. We also need the connectability of the app before connecting. So we could also say, we want an observable of Boolean, right? Did I spell that wrong again? Sorry, my typing is off today. Oh, no, I see. It's just this is not formatted yet. Yeah, there we go. Well, that's annoying. Okay, so this is like connections or something, right? True would be it's connected. False means it's disconnected. Something like that. You know, the model doesn't have to be perfect now. We could enhance it if we need to. You know, the bool might change to some type that gives us more information at some point. Hence why object-oriented programming might actually end up being something we use quite a bit. It most likely will, because it's going to serve the purpose of being the types that we push through as notifications for many of the observables we write. But anyway, for now, a Boolean suffices. So we also need this to be, you know, set as input because we need to have two observables here that we could subscribe to in order to implement a rule like this. The user can set their username before connecting. Now, what this means is we have to decide what it means to try to set the username if you've already connected. But that could be as simple as just ignoring any strings that are pushed in because there's no purpose for them. But it could be that we have to throw an exception and crash the app because that was something unexpected, for example. We have to decide that as we go, but for now we're going to be very simple and just assume that anything that's not defined in the spec doesn't need to be defined in the program either, right? So we'll define what it means to set the username before connecting, but we'll leave it undefined what it means to set the username after connecting, okay? That will keep the code looking very much like the spec as well, and, you know, obviously if we need to put more details into it, because the spec is obviously not going to be complete. Most specs aren't. The first draft is going to be missing a bunch of details that you're not going to know until you start trying to build the application. So we'll improve the code over the spec as we need to, right? This is good so far. We have this concept of the input into this for this rule, but do we have the concept of the output? We really don't have any reason to define output for this yet because you know, pushing the username through, like username changes as output, isn't required by this rule. It's something likely we'll need at some point, but I'm not going to add it until we know we need it, right? We'll look through the spec, and when we get to the point where we need to know that the username has changed, for example, right, as part of the, you know, like a UI component might need to know that, for example, then we'll define the rule for that, and we'll define it as output. I'm going to delete the object-oriented part of this because I don't want to confuse anything, but I just wanted to be clear about the correlation about how you would go from this thinking in terms of types and state and behaviors and methods and functions and so on to streaming asynchronous streams of data, right? Which seems kind of weird even in something like this, a rule like this, but hopefully it's clear now that it's you know, doable. Now, the benefits of it might not be clear yet, but we'll get to that at some point when we start actually building this in real code. Okay, so we have the user can set their username before connecting. The username from their last session is displayed by default. Could this be reactive? Well, it doesn't have to be because the username from their last session is displayed by default. It implies that when the application starts up, right? Well, this is part of the startup. Oh, it's not. This is part of connecting to the server. I skipped the startup. But I would say this would be something that's really part of the startup rule, right? So maybe it's just in the wrong place. Start the GUI in the following state. Server URL field, username field, and connect button are enabled. Yeah, I would put this here. Let me just move this because this rule doesn't make sense where it was. So start the GUI in the following state. The username from their last session is displayed by default in the username field. But once the user changes it, we're not going to have to deal with the last session again, right? Or the last saved username or anything like that. So that doesn't have to be a reactive stream, right? It's not going to change. It's a one-time thing. We start up, we pull that information from somewhere, and then we move on. So let's move on to rule number 2. The user must enter a service URL and click a connect button. Interesting. So the user must enter a service URL. So we're obviously in familiar territory now. I'm going to delete these numbers because I'm not sure that they really add any value. We're just going to list things top down, right? It's formatting it properly here. Let me just make sure we're getting new lines here. Oh, we're not getting new lines. Then you know what? I could just do it like this. 1, 2, 3, 4. And now we should get a block of code. Yeah. Okay, very good. So now we want to add another thing here. Observable of string, or actually in this case we'll use the URI type, system URI, and that's going to be our service URLs, plural. Because when you disconnect, you might want to change the URL you're connecting to. Possibility, right? That's a possibility. So that's also a setter only because it's our input. What else? Clicking a connect button. Okay. Observable of unit. Unit is sort of like the void. It's not really void is like a dimensionless type that represents, you know, legitimately nothing, like 0 dimensions of state. But unit is sort of like the one-dimensional void. It's a void in the sense that it has no useful information in it. It's void of information, but it represents a placeholder for a type where it's needed, right? So we can't use void, for example, because that's not a type that you could apply in a place where a type is required. At least the C# language doesn't let you do that. But we could use the unit type, which is provided by Reactive Extensions Framework, the RX framework, in rx.net anyway. This type allows us to represent a sort of void value in the placeholder, in this case for a notification. So an observable of unit is an observable that we subscribe to specifically for its notifications. There's no data or state in the notifications that we care about at all. It's just the time factor that's the only thing we care about. When is it being fired, right? So an observable of unit is a perfect model for a button click, for example, or we'll say connects. Because every time you click the button, we don't really care about anything other than the fact that the button was just clicked at that moment. So observable of unit is good there. The click event on a button, for example, doesn't carry any useful information for us that we're going to need to deal with, and at least not as far as the specification for this application is concerned. So this is a good enough model for that. Before we move on, I want to point out the 4 different types here. It's important to realize when you're modeling something as an observable, excuse me, when you're modeling something as an observable, that the data you pass in should be very rich, right? It should be, the notification should have information that's applicable to the context of the notification. And it should have enough information for the downstream processing to do its work without having to look too far to reach to other dependencies. That's important. Of course, the question of mutability then will eventually leak into that concept. You'll wonder whether or not it makes sense to have a type here that's mutable. But generally, the rule of thumb is to avoid mutable types as notifications. But sometimes it's useful. There are certain patterns that can be very powerful having mutable types. But I don't want to get into those now. They're pretty advanced concepts, and maybe we'll get into them in this application, or maybe not. Hopefully we will. Maybe I'll try to engineer some way that we'll have to deal with that just as part of the learning experience. But it's something that is realistic, right? You do find yourself from time to time dealing with types that are mutable, and it becomes tricky to get that right sometimes. So try to avoid mutable types if you can in notifications. Only move to mutable types after really thinking it through and considering that whether or not it's actually the best approach. Also, like I said, you want to be rich in the information that you provide. So that might be a little counterintuitive then, or contradictory to using the unit type then here. Why not provide additional information? The reason is that you also want to be sort of discrete with the observables, right? You want cohesion. Just like in the object-oriented world, right? We don't want to have duplication, and we don't want to have too much of a coupling, right? So, for example, for usernames, so when you connect, it's important to know the current state of the world, right? Like we need to know what the current service URL is and the current username. It might be tempting to like try to stuff that information into here to say when it connects, you get that information. And that's not totally unreasonable. The only problem is we know we also need these observables as well because part of the rules here are going to deal with input validation. Maybe I'm looking ahead a little bit here. If we started it in a way that, you know, like maybe we ignored this one first and we just saw this connect button one first, then it might have made sense to start with unit instead of unit, have like a tuple or a more discrete type that's maybe a little bit better, like, you know, connection context or something like that, which has a string which represents the username, and the URI, which represents the service URL, and maybe any other information we might need. But then immediately you would notice that we then have to start dealing with validation, and we might want asynchronous validation, right? We might want immediate validation, immediate input validation. So as I'm typing, I might want the box to turn red, for example, if I enter a service URL that's invalid. It can't be parsed, right? So I shouldn't have to wait for the connect button to be clicked in order for that validation to happen. That's not necessarily a requirement. I'm just saying that if that is a requirement, in this case, it might be nice to have, so I'm going to do it that way. But once you have that separation, it begins to make less and less sense to sort of force the data from multiple observables into a single one if you need those as well. The state's going to have to be somewhere, but let's let the state live where it makes the most sense. It might just be in our query somewhere. We don't have to force it into one particular observable, but it's important, in contrast to what I said before, it's important to keep in mind that you should always think about providing a rich set of data whenever you design, whenever you define an observable. You should always consider having the type that you're passing in rich and stateful, right? So that way downstream processing could do its work without dependencies. If you actually need the dependencies for other purposes, then you're going to have to deal with multicasting and actually publishing these things, and that way subscribing to them in multiple places and so on. And we'll get to that once we start implementing this, but the key here is that if you're going to add richness to your types, which is a good thing, make sure that you're not duplicating any information as well, right? Because then things will just get confusing again. So you want to keep things streamlined and simple. So unit is perfect for us in this case because it's just telling us the user wants to connect. And we'll already have the other information because it will have already been validated. So we can write a query that is stateful and keeps whatever the latest username is and the latest service URL, for example, and deals with it that way. Okay, and I should also point out, I guess this is a good good place to point this out. Some of this is subjective, right? The objectivity here is going to be in the cost versus benefit analysis. Is reactive programming worth it? Is a reactive-first approach worth it? I'm quite sure the benefits totally outweigh the costs, and I'm hoping you'll see that by the end of the series, and you'll agree with me. But so the point is that there's many different ways to solve these problems, right? To model these business rules. So you might find a different way to do it. You might find a little bit better for various reasons, and that's okay. So there's definitely some subjectivity here as well. And that's important to keep in mind. So I'm making decisions based on what makes sense to me. And if things are slightly off for you, well, that's okay. You could have done it slightly differently. But as long as the end result is close, it reads like the spec, then that's the goal here. And my goal is to show you how you could do that, right? How to program with a reactive-first approach in mind so that you can write code that's very minimal, succinct, clean, maintainable, reads like the spec, declarative, and a whole bunch of other buzzwords. So let's move on. We see here that we have the connect button. When the connect button is pressed, well, we've got an observable for that, and the username is valid. Notice the when here, right? We're finally in the world of reactive programming in an explicit way. The spec is calling it out, right? It's saying asynchrony is important here, right? This is something we might have modeled as an event, for example. But notice the event has to deal with 3 different things that we need to be able to compose together. And now that we have observables, it's going to be much easier for us to do that. So we're already seeing the benefit of thinking in these terms in a theoretical setting. But we're going to have to actually implement this at some point, which I will do. So when the connect button is pressed and the username is valid, we have a username observable. And the service URL is a valid URI. We have a service URL for that, and we have to decide whether or not we want to have validation as part of the observable or not part of the observable. We'll get to that when we start actually programming it and seeing. Once we start trying to solve the composition problem, those kinds of questions we'll have to answer them, right? Do we need more than one stream? Do we need to share the stream? What are the queries on top of the stream? Do we need to share the query on top of the stream or just the underlying stream alone? Etc. Okay, and the service URL is a valid URI. So if all of these things are true, we actually have some output now, right? We're getting into the world of output. Disable the connect button. Now, disable the connect button, your intuition as an object-oriented programmer or procedural programmer is to create a function that disables the connect button. But if you take that approach first, you're missing the point again, right? Which is, we're talking about streams. We're thinking in terms of streams. If disabling a connect button requires no data, right? We're not passing anything to it. It's just it's sort of like a parameterless function, this hypothetical disable function, right? Then that would be kind of like a void, right? Or if we need a single type to represent a placeholder, we would use a unit. And we know that the connect button might be enabled and disabled and enabled, disabled many times throughout the lifetime of the app. So it could be disabled multiple times. We could actually have an observable of unit that would be useful for representing, disabling the observable. As a matter of fact, this could be our first getter, and it could be called, disable. We say can connects. Actually, I'm getting a little ahead of myself. So I was going to say like disable connect or something like that. But what I was just about to say is that this is good, but it's not perfect because we have to assume, even though I haven't read the rest of the spec yet, there's going to be a place where we say now enable the connect button, right? And that could that could happen multiple times. So we're going to end up having a stream of enables, right? Something like this. And this is fine, but then again, could you possibly have a disable and enable happening at the same exact time? That's a race condition, and it's something we'd probably want to avoid, right? So in the reactive world, having an observable is it's more specifically an observer, but we could just think of it in simpler terms. Having an observable means the potential for concurrency. Okay, it's a concurrent programming model. What this means is that if you have two observables, then you might have two things happening at the same time when you subscribe to them, each of them, right? As a result, that means we're actually implicitly modeling here the ability for the disabled and enabled connect streams to both fire, so to speak, at the same time, or push a notification at the same time. And that's not really what we want. We don't want that race condition. What we'd prefer to be able to say is you can either say that it's the observable can either push a notification that it's disabled or that it's enabled, and it can only be one at a time. And we have to service, the upstream observable implementation pushing the notification has to wait for the downstream notification to be processed first before it can continue, right? So essentially we want it to be a synchronous mechanism wrapped in a concurrent programming model. So we get that for free with RX, as long as we're using RX generator functions or RX operators. They guarantee one of RX's contracts that notifications are serialized. So for a single observable and a single observer of that observable, all notifications of that observer are guaranteed to be serialized. Now, if the observer introduces concurrency itself, well, then all bets are off. But as long as it's performing some synchronous, blocking operation, the observable cannot push through any other notifications. This makes it great for us as programmers. We don't have to worry about locking in all of our observers, right? Because unless we're really doing something orthogonal to the monad and to the to the query, right? In which case we might have to deal with synchronization ourselves, but there's ways around that using declarative ways around that as well. But we'll get into those once we get into those. For now, just all you really need to know is that given a single observable and dealing with it in the right way, RX is going to guarantee that we don't have to use locks in our observers because we're only ever going to get a single notification at a time. So it really simplifies the programming model for us, but it still represents a concurrent programming model because if you have multiple observers, they may be firing at the same time, okay? And it also represents concurrency with respect to the subscriber. So at the point of subscription, the code that's doing the subscribing can now go off and do other things, right? So it's truly concurrent in that sense. It's actually asynchronous because it could be single-threaded asynchrony, which is not concurrency but still asynchronous, and that's something that happens on the UI thread. And if you're using like an event loop scheduler, so these are more advanced concepts, but we'll get to them as well. So I'm just trying to point out that the concept here, the takeaway, is that if you're dealing with multiple observables, you have to assume that it's possible for them to be concurrent, unless you're aware and controlling the concurrency yourself by synchronizing or pushing through to a single thread, or like some sort of queue or something like dispatcher on a UI thread or an event loop scheduler. But most of the time, especially in a business layer, you're not doing that. You're just remaining free-threaded, which is the nature of RX, which is any notification pushed through on any thread will just be processed on the thread in which it's being pushed. So if we're going to block to do the operation, then the generator of the notifications is going to have to respect that in order to respect RX's contracts, and that's extremely important. It means that our programming model is simplified. We don't have to worry about locking. It's guaranteed as long as the observable source respects RX, satisfies RX's contracts. So that's very important. Now, it matters in this particular scenario because we can condense these two observables into a single observable to take advantage of this serialized notification contract for free. So if we just change this to a Boolean, for example, and we just change this to, say, Ken connects, then these are notifications that indicate whether we can connect or not. So the UI can subscribe to this output of our reactive program, and whenever a true comes in, it could enable the connect button. Whenever a false comes in, it could disable it. And it's guaranteed to only happen one at a time in a serial fashion. Now, it's probably worth pointing out that if we're marshalling to the UI thread anyway, as I already stated, using a UI thread makes that guarantee for us as well. It's natively guaranteed. It's inherently guaranteed in the fact that we're only using a single thread to process events, right? So in an event loop, you're guaranteed to only have one notification at a time being processed. And other notifications that come in concurrently will have to be enqueued. So that's single-threaded asynchrony. In our case, if we're going to end up marshalling to a UI thread anyway, then that part of this solution doesn't matter as much. But what's also important here is that we're also getting a simplified design where we only have to deal with a single observable now with a Boolean, because the Boolean is, like I said before, it's richer information. The unit would have worked, but it wasn't quite enough information, and we don't, at this point, we don't need or have any reason to believe that we're going to need two separate observables for disconnecting and connecting, or enabling and disabling the connection button. So for that reason, having a single observable and enhancing or enriching the data in it as part of the notifications makes much more sense. The ancillary, or I should say rather, the additional benefit of the serialized notification aspect might not be useful to us if we're going to end up marshalling to UI thread anyway. But perhaps this could be something that isn't going to be marshaled to UI thread. Maybe we have a web client that we eventually implement, and therefore subscribing to this observable means we're going to be pushing notifications over a WebSocket or something. In which case, we have to guarantee the serialized notification requirement anyway, because we're going to have to depend on that when writing to a socket, right? When sockets are streaming and we're not going to be able to write to the socket at the same time, multiple packets of data. We're going to only be able to write one at a time. It's a stream. So RX's contract makes it really easy for us to consume this observable then. We don't have to worry about locking. We just write directly to the stream after we subscribe to the observable, as long as the observable satisfies RX's contracts. There are RX contracts that I'm not talking about here, like the RX grammar and so on, but the RX design line design guidelines document in the RX repo in GitHub outlines all of that. So I highly recommend reading that. It's a very important and useful and interesting document. I'm not going to go into any more depth about these contracts, though. I'll just assume at this point you understand what I just said, even if it was a little complicated, but there's a lot of information out there on these things, and like I said, I also highly recommend you read the design guidelines document, and you'll get a better sense of what I'm talking about. So anyway, this is a nice simple output mechanism here. So far we could see that we're going to have to write a query that somehow combines these input observables, which we already have a spec on how to do that. So we're going to try to write code that reads very much like this spec, right? Given these observable inputs, we need to generate this output, right? But there's other output we need to generate. We need to display a waiting animation and a cancel button. right? So what does that mean? Does that mean that's something that we have to generate from the business layer of our program? Probably not, right? Awaiting animation is presentation logic. So, displaying awaiting animation by reacting to a certain notification from the business layer is something that would make sense in the presentation logic or the presentation layer. So we will have code for the presentation layer that will deal with, awaiting that notification and then, making an animation visible or whatever, starting a storyboard or something like that. And then also showing a cancel button and hiding the connect button or something like that. But we don't need to spec that out here because I'm trying to focus more on the business layer. Let me make that clear, actually. So this is reactive programming. This is, say, business layer. Right, so maybe in the future, I don't know that I'll actually end up writing this out. We might just end up coding it directly. I'm just starting with writing this out now just to give you some general guidance on what we'll be doing here. How we'll, the way in which I'll be thinking about these problems as I'm solving them in code. But once I get to code, I probably won't come back to the spec again. I'll just stay in code from that point on. But maybe I'll leave a placeholder here in case we want to add some stuff for the presentation layer as well. But it's going to be the same thing, right? It doesn't matter which layer we're in. It's the same problem, same approach. Find the input, find the output, build a query that glues the two together, right? And we don't care who implements the observables, and we don't care if they come over from the network, or if they come from the local process, or if they're loading data from a file, right? Or if it's the user pressing a key on the keyboard, or clicking a button on the mouse, or it's a device raising some event, a native device that we have to now translate into an observable. And of course, again, respect Rx's contracts. We don't care where the data comes from. That's the beauty of this abstraction, right? We just care about respecting time and the streaming aspect of the problem domain, and then how to actually glue them together. That's the important part, right? Okay, so now we have observable Boolean of can connects, and displaying a waiting animation and a cancel button. I think we're going to defer to the presentation layer, right? But we do want some notification from the business layer to trigger that. So will this be good enough? If can connect is false, then that means you're connected, right? You know what? Maybe can connect is not the best way of describing it. We'll just make it a getter on connections. This could actually eventually end up being one property with a getter and a setter, right? So you could pass in your notifications that, oh, actually, you know what? Connecting is not input into the system. Connecting is essentially output from the reactive program. So it's purely output. Yeah. Okay, good. So yeah, I think that makes more sense. So calling this connections makes more sense. The UI will subscribe to connections, and when it's false, when it's true, it will disable the connect button and display a waiting animation and so on. And that query will be part of the presentation layer reactive program. But we'll get to that when we get to that. This code could run on a server. It doesn't matter. We don't care where we'll figure out where it's running. It's obviously going to run client side in our WPF application, our desktop rich client application. But if we were building like a web interface or something, this could run in JavaScript on the client side, or it could even run on the server side and using push notifications to push new HTML or something to the client as things change. There's many ways we can go about using this programming model, but the key is that this model will work on any platform. It's very abstract, right? The benefit of the abstraction being that we're hiding all the unnecessary details that we don't care about. We're just talking about the spec, right? We're just writing the things that are in the spec one by one. Try connecting to the specified URL. A side effect. So this is really our first business layer side effect, because these are side effects, but they're presentation layer side effects. Connecting to a URL to me is a business rule, right? It's orthogonal to the presentation layer or presentation logic. Connecting has to happen, right? So that is a side effect. Now, normally side effects like this are modeled as a method on a type somewhere, right? So we're gonna have to have some sort of client type that has a connect method, right? Or try connect, something like that. But that's gonna be inherently asynchronous as well. And for the C# devs out there, at least, our intuition would then be to use a task, which is actually a good intuition to use. It's a single call, try to connect, and if it fails, we get a task that's faulted. Otherwise, or we get a task that eventually becomes faulted, or it eventually is set with a result, which is the success of the connection. And also would support cancellation, right? So it seems like a nice model for this, actually. But can we think of it in terms of a stream? Let's see. Well, if you can disconnect and connect multiple times, then clearly try connecting to the specified URL could also be a stream, right? It's a stream of connection attempts, in a sense. Now, that doesn't help us with the side effect itself, right? At some point, we're going to have to code the side effect, and it's going to be outside of the reactive world, right? At some point, we're going to be invoking a function on a service, right? It's just the way it's going to happen. It's the way it's got to be. So the question is, what kind of environment do we want to embed this in? Do we want to stuff this in an observable? So my intuition tells me no. The answer is no to that. And the reason is that task as a single one-off call seems to make more sense. So I'm not going to model this as an observable here, but that could change, right? We'll see what happens when we start actually implementing the logic in code. Does it make sense as a task, or does it make sense as an observable with the side effect sort of being part of the query? My intuition tells me that this is going to be like a subscribe call to a query, and then maybe more like a select many, but still do it as just a single one-off with a task response. So we'll get to that when we get to that. I'm going to leave that alone for now. But it is our first business layer side effect, so it's nice to think about that in terms of reactive terms, if it would make sense. I just don't think it fits here. I don't think it's appropriate to do reactively here. Okay, so if the connection cannot be established, or if the service URL is invalid, so now we have some logic that has to happen as a result of connection failure. So downstream in our query, we'll have to deal with that. So I would say we don't need that as input, because the reactive layer will be encapsulating this concept of connecting and disconnecting. So we don't need it as input to the business layer. And it's not output per se, because the side effects are also going to be in the business layer, right? So, well, most of it. This is presentation layer. Okay, so yeah, this is presentation layer. Display any network, service, or URL validation errors. So in other words, we want to let the user know. We want to service to the user that the connection failed in some way. So that's actually important. For that reason, having a connecting observable as output might be useful. And connecting could describe... Well, let's think about that for a moment. So we really only care about two cases as output: success and failure. Right? As far as the presentation layer is concerned, it just needs to know, did it succeed or did it fail? Now, success is sort of implied in this observable, right? If we pass in a true, it's connected. And if we never pass in a true, then it didn't connect. But from the UI perspective, when we start looking at rules like this, disable the connect button, it means that obviously, as you can see here, enabling the connect button is going to have to happen, and it's going to have to happen in terms of failure, right? So if you click the connect button, the UI disables it to prevent you from clicking it again while it's connecting. And if it fails, one of the rules says that we're going to have to re-enable the button, of course, and then go back to number 2 so that you could, the user could start again, try reconnecting, maybe change the URL or whatever. So because of that, it means it might not make sense for us to actually have this as it might not make sense to rely on this connections Boolean observable for that information. right? It almost does seem like we definitely need a separate observable for that. The reason being that connections with a true or false tell us whether it's successful at connecting and whether it's successful at disconnecting, but it doesn't tell us anything about the failure states, right? Connecting as a intermediate observable is unnecessary because we already know that. We have that information because it's here, right? This observable is essentially this observable. So if the presentation layer provides this connects observable, well, then it gets subscribed to it itself to know when it's connecting, right? And it knows when it's succeeded when this returns true. What we want is an additional notification that says when it failed. And that will help us to build out the business rules as well, right? From the UI side of things, we're going to have input into it is the output of the business layer, right? And the output of the presentation layer is the input to the business layer, and so on. So the output of the business layer being this sort of like faulted observable, stream of connection failures, the presentation layer will treat as input in order to implement a rule like this. If the connection cannot be established, then display the error. So if we're displaying the error, including URI validation errors, by the way, which would mean you click connect here, but you're in a state that is unacceptable for connecting, like the username's invalid or the service URL is invalid. We want to push a notification out as well that states as much. So in that case, we have to have some sort of like connection failures, let's say, stream. But we need to potentially distinguish between the types of the data. This is where it comes down to using an enriched type, right? So we can put any type here that we want. We could start something as simple as a string, which is just the error message, but we might want additional information. Was it a particular UI field that failed? In which case we would say which field it was, so that the and what the error was. Username is required or something like that. So some sort of validation type might make more sense here. And this is again where we're going to start moving into the object-oriented world when we get there. But for now, I'm going to keep it real simple. We'll just use a string. And from the UI perspective, the input into the UI, the output from the business layer, will be a string, an observable of strings that it will treat as error information. So when it receives one, it will assume that connection failed. And it doesn't have to know semantically why it failed. Programmatically, the semantics are irrelevant to us. We'll just display whatever the string is to the user. For now, right? So this is the simple approach. But we could always enhance this data, enrich it with more information, this data type. Instead of string, we could create a custom data type like validation or something, and then enhance that for use on the UI or any other. The logging mechanism might want to subscribe to this observable, for example, and log failures, and maybe semantically it would log different kinds of failures in different ways or something. So having enhanced information is obviously useful to us. We just, for the moment, we don't need it, so we'll just keep it simple. Then we have to focus the service URL and select it. Again, presentation layer and enable the connect button, presentation layer. So this is the only output we would really need, I think, to model all three of those requirements. All three of them would subscribe to this. And notice, by the way, the wording here. This is important. Like when you read a spec, you'll see like if the connection cannot be established. And as object-oriented developers, as imperative-style developers, our intuition immediately goes to putting an if statement in some method somewhere, right? But notice here, we're not treating like that at all. We're treating everything as almost as if it starts with a when the connection cannot be established, right? So I wrote the spec up in a way that I think you would normally see a spec. I'd even write it up like this. I didn't think of it in terms of writing it up for reactive programming specifically. And I did that on purpose so that, you could see the problems with trying to map the reactive approach or, a business spec that's written in natural English language into a reactive program. Sometimes it's tricky to do that, and I wanted to make it clear that it often requires a sort of rewrite of the wording, right? And it doesn't. It's a rewrite of the wording without changing the semantics. It's, if anything, it's just calling out the fact that time is a factor in the rule, even though it wasn't explicitly stated, right? When implies time. It implies asynchrony, but if doesn't, in a sense. I guess maybe it does in a sense, but our intuition when we see if is to write imperative code. And my point is you want to train yourself through experience to think in reactive terms rather than in imperative style terms. Okay, let's go a little bit farther here before I end this first video, and I will leave you with a challenge. So if the cancel button is pressed, that would mean that display a waiting animation and a cancel button. Right. So if the user presses the connect button, it disables the connect and automatically shows a waiting animation and a cancel button. Right. Now it's possible, however, that if it's input validation, nothing asynchronous actually has to happen. So you might want to throttle that. Right. In the UI, we might not show this immediately. You might wait a second or something before we show it. Whatever. We'll get to that when we get to that. But again, the beauty of reactive programming is that we could use reactive programming and RX operators to do all of those things, which is really nice. Throttling, for example. But what matters here is that if the cancel button is shown, then we're going to need to react to the cancel button being pressed. So it's not if the cancel button is pressed, again, it's when the cancel button is pressed, and when implying that it might be pressed multiple times throughout the lifetime of the app. So again, it's perfect to represent it as the click event of the cancel button as an observable of unit, right? Notice also the correlation between events, right? So far, the two events that we've noticed, the two really strict events that we've noticed, which are really button click events, map perfectly onto an observable, right? So some observables really just are events. Okay, not all observables, but some are. And we'll get into more details around that as we build out the app. It's really related directly to temperature, hot and cold observables. But for now, oh, and the notorious subject. But we'll get to subject much later. And for now, we just need to. I just want to point out that the fact that this is an event implies time, right? The fact that it makes sense for us to have a click event implies that implies asynchrony, right? There must be some asynchronous operation happening if you can have an event, because the event is reactive. It's calling back a handler, right? So you register the handler to be called back later. That implies time. It implies asynchrony. Okay? So do we need to have input to the business layer of cancellation buttons being pressed? Well, maybe, maybe not. Let's read the spec and see. This could be just entirely UI-related requirement, which again, we'll build a reactive, implementation on the UI layer. But for the business layer, I don't know. Maybe we need it. Maybe we don't. So the first thing says cancel the connection attempt that is in progress. Best effort. So the connection attempt is happening in the business layer. So clearly, our business layer is going to require some input that cancellation is, the user desires cancellation. Best effort. So we need some input for that. What else is new? We'll say cancellations. Oops. Cancellations. Okay, so now we have cancellations. All right, what are we going to do with the cancellation in the business layer? We're going to cancel the connection attempt. Okay, what does that mean? Do we need an observable of connection attempt cancellations, or again, probably not. Similar to how we didn't really need the connect to the service as an observable, but that remains to be seen. Maybe it will make sense to do that as observables as well. Could it be a stream? Of course. I mean, we could really model everything as a stream if we want to. My point is not that RX or reactive programming is a panacea. It's not. I mean, I'm not a purist at all. I think most people tend not to be purists in anything, right? Reactive programming makes sense. The surprising thing is that it makes sense so much more than I think most people realize. My goal is to make it clear that we could use reactive programming first to model almost everything in the app. Time is everywhere, and asynchrony is everywhere, and it's just a clean, nice way of doing it. But it's not going to solve every problem, right? Like I said, object-oriented programming is going to be a significant supporting. It's going to take a significant supporting role for us, and at the end of the day, we'll probably end up writing more object-oriented programming in this app than we do reactive programming. But that's not the point, right? The point is that you don't want to just do everything in object-oriented programming or everything in reactive programming or everything in some other mechanism of programming, functional programming. Having a hybrid is actually often the best. It's also often the most dangerous, right? Some of the most complicated programs out there, overly architected, overly complicated, are, part of the problem is that they deal with multiple paradigms. So there is maybe a bit of an art to figuring out how to deal with multiple paradigms at the same time. But when you get it right, it really is beautiful. It makes a program that's really easy to maintain. So that's ultimately our goal here. And I'm not trying to force reactive programming. The point was that I'm not trying to force reactive programming everywhere. I'm trying to use it where it makes the most sense. So let's move on. If the cancel button is pressed, cancel the connection attempt that is in progress, best effort. Like I said, I don't think that's going to be reactive. It's not going to have to be an observable. It's probably just going to be a side effect that we'll implement by subscribing to an observable that tells us when the side effect needs to be executed, and then executed it in an imperative style. But maybe not. I mean, we'll figure it out as we go. If the cancellation is unsuccessful, now that's possible, right? There's a race condition there. It's best effort, right? So if the cancellation is unsuccessful, then we're going to try disconnecting from the specified URL. Again, a side effect. And if the program fails to disconnect gracefully, then log any errors and continue. So continue means just assume that the cancellation occurred and just move on. And the UI will then enable the connect button. So if the cancellation button is pressed, we do a best effort to cancel, and the UI enables the connect button. But in the meantime, in parallel, right, the cancellation will be happening. If it turns out to be unsuccessful, we're just going to essentially log the error and do nothing. So we'll be swallowing the error in a sense. We're not going to surface it up to the user. I'm really against swallowing errors, except in the very rare cases where it makes sense. This is one of those cases where I think it makes sense because what does it mean for cancellation to be unsuccessful, right? It almost doesn't really mean anything. It's, you could pull the network cable out and cancellation it has to be successful. If being successful is going to mean anything, it's going to mean that you're no longer able to send or receive messages because you've literally removed the hard line, right? So, of course it's possible. It's practically guaranteed, but we might notice some errors because there is a race condition. Okay, if that happens, we'll log that there was a race condition and move on. I don't want to swallow any exceptions, so we'll at least log it, even though it's probably going to be, useless information to us. But also, there's the possibility that maybe we're trying to do a graceful disconnection, or maybe the cancellation doesn't work, so then we have to do a regular disconnection, and it's already too late. We missed the window for cancellation, so now we have to actually disconnect from the server, and that itself may come with some problems. So if we get an exception thrown during the disconnection phase, which is highly plausible, right? I mean, even if we're trying to do a graceful shutdown of a socket, it's possible that we're going to get an error. And if that happens, then we're going to want to log the error and continue anyway. There's nothing we could do at that point, right? But that. Now, if the user tries to connect again while this is happening, that's okay because, the connection might fail. And if the connection fails, we already have the flow of what to do when the connection fails, including displaying any errors to the user. So, they'll click connect and wonder why it's not working. But there's nothing we could do about it at that point, right? So we just need to try to build a system that's more robust and avoids this possibility. But at least here we're capturing the fact that we're going to log any errors that may happen, and errors may happen. We don't want the app necessarily crashing for this particular case because it's expected. There will be exceptions because of race conditions and so on, and network programming, right? It's not, we can't assume it's 100% reliable, so we'll deal with it. And I called that in the spec because it's important, but it looks like it's not really a reactive problem for us, at least not at the moment. So we don't have to change our model at all or add anything to represent this, I think, for the moment. And we don't have to surface any output, right? Because, the fact that it failed, there's no real requirement there. We're not going to display it to the user. We'll log it as an error and continue. That's something that could remain entirely in the business layer. We don't need to expose that as output from the business layer. Right? Let's look at this next one here. If the service requires authentication, interesting. Now we're getting into some logic that also involves user interaction. I'm going to leave this one up to the viewers. If the service requires authentication, is that reactive or not? And then we need to prompt the user to enter a password. Is that, from the terms of the business layer, is that something we want to surface as input or output? If the server rejects the password, right, then we need to enable the connect button. So this is an interesting one, maybe a little tricky. I'll leave this one up to the viewer. See if you could come up with a model, kind of like I did here, sticking only to the business layer. The presentation layer stuff you could skip, or if you want to try to add that too, that would be interesting, probably. And see if you can come up with a model, and then in the next video I'll implement it, and we'll see how they compare. And I think my goal will be in the next video to actually get into the code rather than just specking things out here. But I'm hoping this video was at least useful as an introduction just to the thought process, right? From now on, I think we'll actually get into the real code. My recommendation to you is, if you want to experiment with this on your own, is to just stick with the thought process for this one exercise. See if you can come up with a model for this. Maybe move into the presentation layer and do the presentation layer stuff as well, like I did here. Which observables would you need as input and output to glue to these? That might be interesting, right? And we'll eventually get to those in the next video. All right, so thanks for watching.